Good day, class. My name is Pythagoras Rule. I'll be taking you mathematics. And our class for discussion this morning will be in SS1. It will be for SS1. Now, we'll be focusing on a topic titled trigonometry. Before we commence our class, we'll take a brief look at our instructional objectives, because there are some things that the student or you ought to know at the end of this particular class. First, let's look at objective 1. The objective 1 says, define trigonometry. You need to know what the topic trigonometry itself is talking about. 2, apply the trigonometrical ratios that deals with sine, cosine, tangent to solve right angle triangles. 3, we'll combine trigonometrical ratios with Pythagoras Theorem to solve right angle triangles. So, let's take the class in full. It's movement. What is trigonometry? Trigonometry is a branch of mathematics that studies the relationship between triangles. The relationships of sides, length, and the angles in a triangle. In that triangle, we have different parts of that right angle triangle. As you can see here, this is a right angle triangle that is labeled with different parts. I have the first part, which is the longest side here. It's called the hypotenuse. In a right angle triangle, when we talk about trigonometry, we must know what is the hypotenuse. It is the longest side. Then we have the opposite sides. The opposite side in a right angle triangle is that particular side that is facing the angle theta. Then we have the other side, adjacent. Now, further, in trigonometry, we have 3 relationships. Sometimes I call them 3 brothers. We have the sine, we have the cosine, and we have the tangent. The short form for sine, we say sine. Then cosine, we say cos. Then tangent, we say tan. Having understood what is the sine, cosine, and tangent, we now come back to an abbreviation, SOHCAHTOA. What is SOHCAHTOA? SOHCAHTOA simply means sine is for so, which means opposite over hypotenuse. What is ka? It means cosine, which is cos theta. From this our right angle triangle here, which means adjacent over hypotenuse. Then we come back to tangent, which is toa. Toa means opposite over adjacent. Now, this is a second triangle to discuss the position of the angle in a right angle triangle. The first triangle talked about the 2 acute angles that are found in the right angle triangle. Since we have 90 here, the other 2 angles are acute angles, which when you sum up everything must give you 180 degrees. Now, if you observe carefully, my position of my angle has changed. Once the position change, the opposite side will automatically change. But if you observe, my hypotenuse is constant. Opposite and the adjacent, they will alternate each other, depending on the position of angle theta. So if you look at it now, opposite is now down, hypotenuse remains, while adjacent is now on the other side, which rounds down to sine theta. From our SOHCAHTOA, we have opposite over adjacent over hypotenuse. Cos theta, we have the adjacent over hypotenuse. And tan theta, we have opposite over adjacent. Now let's quickly take some examples to make us understand it better. Example 1 says, calculate the sines of theta in the figure below. We have a right angle triangle. When you are given this type of question, the first thing you identify is that where is my hypotenuse, where is my opposite, and where is my adjacent. The longest side, the side facing the right angle, is always your hypotenuse. This is your hypotenuse. The side facing the angle, if you observe now, 5 is facing theta. So 5, it becomes my opposite. Then 4 becomes the adjacent. Having understood that 5 is opposite, 4 is adjacent. Your question now is that from the trig ratio, the sine, cosine, tangent, which we summarize to be SOHCAHTOA, which of them will I use? I have opposite and I have adjacent. Therefore means I will go and use my tan. Is that clear? Good. Tan theta is opposite over adjacent. Remember, the question says we should calculate the size. How large is that angle theta that we are looking for? We want to know how heavy it is. So, bringing it down, you convert this to decimal, you change it to decimal. And changing it to decimal, we have 1.25. That is not theta, because it's in decimal form. Now, for us to get the angle, we'll take our 4-figure table. You go to tan table. Everybody move to tan table. Locate where you have 1.25. Or if you have your calculator, you press the tan inverse of theta, shift, and tan 1.25. Theta will come out to be 51.3 degrees. You have gotten the size. So the size of this angle theta is what now? 51.3 degrees. Also, we have example 2, which says calculate the size of theta in the figure below. If you see the difference between the first question and this, the position of the angle has changed. What we are trying to relate to you here is that we are trying to tell you that the angle can take either of the two parts, excluding the 90 degree, which is the right angle. So, look at this again. I told you. Observe. When you see a question, the two questions you ask yourself is, where is my opposite? Where is my hypotenuse? The other one will be fixed. From here, the side facing the angle is 9. So 9 is my opposite. The longest side here given to us is 20. So we have our hypotenuse. In SOHCAHTOA, so means O and H, which is sine theta equals to opposite over hypotenuse. We come back to simplify. Sine theta, 9 is opposite, 20 is hypotenuse, which gives us in decimal form 0.45. You go to your log table, under sine, locate where you have 0.45. If you are not within the reach of your log table or your 4-figure table, you press your calculator, sine inverse, shift, sine. You press shift and sine 0.45. It will take you to 26.9 degrees. It is not degrees because we have converted it. We have now seen the size of this angle, theta. Then look at number 3. Example 3. Say calculate to two significant figures the values of x. Remember, I defined trigonometry as that branch of mathematics that studies the relationship between the length, the size, and the angle. So it's not just angle we look for, we still look for the sides. Now, getting the side, the same application. When you see a right angle triangle that is given to you, you locate your 3 points, my opposite, my adjacent, and my hypotenuse. Here, x is facing my angle here. So x is my opposite. The longest side here is 10. So I will still apply sine. So sine says x over 10. What will I do? For us to clear this is already a fraction. We must clear the fraction. So clearing the fraction, you cross multiply here, which will take you to x equal to 10 times sine 78. What is sine 78? If you go to your 4-figure table, sine 78 is 0.9781, or you punch your calculator. Just punch sine 78, it will display the figure. What you do, you multiply 10 times 0.9781, which will give you 9.781. Remember the instruction. Even in WAEC, that instruction is very, very important. To two significant figure, you will round it up. When you round it up, what significant figure begins from the first non-zero digit from your left-hand side? Now, this is the significant figure. So I will round up 8 and add it here. That is where I have my answer to be 9.8 centimeters. Okay, having understood how to differentiate between the sine, the cosine, and the tangent, and when to use it, we have some exercise here. The first one says calculate the size of theta in the figures below. We have A and B. Then question 2 says calculate theta and rho, hence find the size of triangle PQR. So this is for your consumption. So work on it. Let's see how far and what will be your answers if you can solve the solutions. Okay. We look at another subtopic under trigonometry. You can't discuss trigonometry without coming back to Pythagoras Theorem. This Pythagoras Theorem is what we've been dealing with, some of us from basic school, primary 5 or 6, and in JS2. Now, it's a theorem. This theorem states that in any right angle triangle, the square on the hypotenuse is equal to the sum of the square on the other two sides. For instance, let's take this triangle. This is a right angle triangle. I have triangle ABC. Now, if ABC is here, from this theorem, it says that for you to get the small letter a here, you must square this and square this. Add them together to give you a square. That's what the theorem is saying. So we are going to be applying this theorem and link it to trigonometry and see how far we can relate both of them together. Okay, having understood what the Pythagoras theorem is talking about, which says the square on your hypotenuse is equal to the sum of the square on the other two sides. We'll take an example. The example says, using the Pythagoras rule, find A in the right angle triangle below. We have our triangle here, triangle ABC, and we are given two sides. We are given side B and side C. We want to find side A. From the Pythagoras theorem, we state that A squared must be equal to B squared plus C squared. What is A squared? That is our bone of contention. So, B is 6, 8C is 8. So 6 squared is 36, 8 squared is 64. When we add them together from the rule, it gives us 100. So A squared equals to 100. We will not stop there. What we are asked to look for is A. So how do we eliminate the square? we take the square root of both sides. Taking the square root of both sides, the square root of 100 becomes 10. So our A is 10. Looking at example 5, from the relationship between trig and Pythagoras Theorem, so given that tan theta is equal to 4 over 3, find the value of sine theta plus cos theta. This is where I want you to pay proper attention, because we are now combining the two subtopics together. You will remember, tan is twa, opposite over what? Adjacent. And that means you must have one of the side facing the angle, and the other side must be the adjacent, because tan does not have to do with hypotenuse. So we have 4 over 3. If you see now, my theta is facing 4. So 4 is my opposite. Now, coming back, for you to get sine theta plus cos theta, you must apply the Pythagoras Theorem, the rule. It is the rule that will enable you get the hypotenuse in this question. Now, let's look at the solution here. By Pythagoras rule, we have a squared equals to b squared plus c squared. You agree with me that we are looking for a squared from our previous example. Now, bringing it together, b is 3, c is 4. 3 squared is 9, 4 squared is what? 16. When you add them together, you get what? 25. Our consign is a, not a squared. So a squared equals to 25. You just take the square root of both sides and you get your 5. The question says, find the value of sine theta plus cos theta. And this A is just a stepping stone. It's just a way forward that will enable us get the real answer to the question we are asked. Now, to get sine theta plus cos theta, you bring it down. Sine is, we have so. We have ka. Sine is opposite over hypotenuse, which is, if 5 is here, I have opposite over hypotenuse, which is 4 over 5. Then my cos is adjacent over hypotenuse, which is 3 over 5, which is what I've written here. Then we'll come back to our basic arithmetic, plus and minus. You add up together, they are the same denominator. The LCM is 5. So 3 plus 4 is 7. So our answer becomes 7 over 5. Therefore, sine theta plus cos theta is equal to what? 7 over 5. Having understood this topic on trigonometry and Pythagoras Theorem, we have some assignments for you. I have about 2 assignments here for you. The first one says, given that sine theta equals to 5 over 13, find the value of sine theta plus cos theta plus tan theta. Then number 2 says, find the value of x in the figure below. The diagram is on the board. Once you finish this assignment, please don't forget, I have a mail on the board. Please do well to send your assignment on or before Monday next week, to enable us give you feedback. And I want to advise you, stay safe, observe all safety measures. God bless you.